Okay. All right. Remember that problem that you had that was taking the derivative of something to the third power. And we had to do all the algebra to elongate that and get one long polynomial. Well, there's a rule for that. And so now you don't have to do that anymore. And I know you wished you had that rule now, but if you have a function that is something raised to a power, you're going to use the chain rule. And don't get caught up with this terminology. It's like if you have a function, you want to take the derivative like you know to do, and then you take the derivative of what's inside and you multiply by it. And that's going to make more sense when we see the numbers. But that's the alternate form kind of makes more sense. You take f prime of the whole thing, letting what's in parentheses just be something. Think of it as u or think of it as something other. And you just take the derivative of that, and then you multiply by the derivative of what's inside. So it's going to make sense when we're looking at an example. Sometimes the lingo, the math words, are harder to understand than actually doing it. Okay, so say we were going to take the derivative at the bottom of x squared plus 5x to the 8th. You wouldn't want to multiply that out 8 times. That would be beyond comprehension as far as amount of work it would take you to actually get that finished. You don't want to do that. So the rule says take the derivative as if this were something plain. So what would you do? The 8 would come to the front, and you'd have this, and what would the 8 become? 7. So your first step, okay, and I just wrote down, think of it as something to the 8th power, and the inner layer is this thing, all right? So you told me that was 8 times that to the 7th. You know to do that. Then you multiply times g prime of x. That means take the derivative of what's inside. So what's the derivative of this inside part? 2x plus 5. So you have 8 times this to the 7th times 2x plus 5. It's called a chain because you kind of keep doing that. You don't finish by just writing 8 times that to the 7th. You have to take the derivative of what's inside, sometimes called the argument. How many of you have had trig? Hopefully a few. Well, in trig, you hear that a lot, the argument, but you'll hear it here too. All right, and the only thing, you could write 8 times this, so you could write it as 16x plus 40 times that to the 7th, because you can't do anything with that. Okay? Called the chain rule. Yeah, that's what that, I was just saying, multiply the 8 times that. And sometimes you can do that when it's easy enough, but you might have another piece down there that was also raised to the power or something, and sometimes it won't be the case, but most times it will. Does that make sense? And so now, if you didn't get to that problem or you didn't finish that problem, and from here on out, you won't ever want to do that. Oh, let me multiply all that out. You'll just use the chain rule. Okay? All right. Let's try this one. Negative 8x to the 4th plus 10x squared. Can I move up enough to get that up a little bit? To the 3rd power. So it's like something to the 3rd. So it would be 3 times this thing to the 2nd times, and we're going to take the derivative of what's inside. And the derivative of what's inside is negative 32x to the 3rd plus 20x. Does that make sense? Derivative like you know how to do times the derivative of what's inside. Okay? And then the only thing you might do is go ahead and multiply your 3 times this, and we'd get this. And you have negative 8x to the 4th there. You know, on a test, if you got to this point, you know, I would give you that. I'd like you to go this far, but if you had here, then that's, you know, you did the work. The thing with grading calculus tests, particularly with derivatives and integrals, you do a lot of work, and say you had the whole process right, but you can't add 2 and 3, and so you had 6 in your answer instead of 5. Well, I'm not going to count that all wrong. That's just mean. So, but do try. I mean, you wouldn't get it totally right, but maybe a couple of points for not being able to add, but being able to do the calculus, that's worth something. So, but be careful. All right. Are we good to move up to the next one? All right. On this one, the deal is you have to recognize it as a product. You can't multiply 4x times that thing because it's raised to the 5th. So this is a product. So I went back to writing the roadmap because it helped me out to know where I'm going to take the derivative. So I have 4x times the derivative of this thing plus that thing times the derivative of 4x. Noticing that when I take the derivative here, I have to use the chain rule. So the new stuff we just learned comes into play right here. So you have 4x times, and here's the derivative of that thing, 5 times that to the 4th times 3. Where'd the 3 come from? It's the derivative of what's inside. So the derivative of this thing, 3x plus 5, is 3. And then 3x plus 5 to the 5th times derivative of 4x is 4. So in this step, all I did was take the derivatives of the yellow pieces. That went there and there. All right, the next line, these things are outside the parentheses. So I could multiply all those guys together, 4x and 5 and 3. That became 60x times that plus 4 times that to the 5th. And if you think back to your algebra, what do you recognize in that? I can't collect like terms, but do I have some things that are kind of the same in both pieces? Okay, in the 60x and the 4, could I pull out a 4? I'm just thinking about what's common in both pieces. And when you look at these two guys, you can pull out 3x plus 5 to some power. What power can I pull out? To the 4th. You can pull out the lowest one because you can't take to the 5th out of something to the 4th, but I can take out to the 4th. So you're going to factor out 4 times that to the 4th. I'm going to pull that out of both pieces. So when I factor it out, I'm left with 15x right here and nothing there because I pulled that out, right? I'm dividing this whole piece into that piece, and I'm left with 4. Does that make sense? I mean, I'm left with 15x. I was saying the other way. All right, plus when you pull out 4 out of this, that's gone. And what am I left? I'm left with one of those, 3x plus 5 to the 1st. When that happens, I can collect terms here, and I have 18x plus 5. And then that on the outside, and you would probably just leave it like that. They might expect you to multiply the 4 times that and get 72x plus 20. I didn't do it there. Okay? Those are just examples. Those aren't problems yet. Is that what you're... Okay.
So it's going to have us factored out.
I think you will have to do this business in some places. Okay? We haven't hit the regular problems, so we'll know. We're going to work the problems in a minute. Okay. Are we ready to go to those problems? Let's do it. Okay. All right. Okay. They, of course, start out fairly easy. So what's this going to be? 5 times what's in here to the what power? 4 times, what's the derivative of this guy? And I actually think that's what I have as the answer. So on MathLab, it may let you leave it like that. If it doesn't, if you have that, you know the numbers are right, or you might look at show me an example and it'll show you the format that it's expecting. But I think that this is it. Okay. All right, let's try the next one. And on this one, it was funny. I think they wanted you to go further. And there's sometimes no rhyme or reason. Sometimes you can tell, oh, it started out with a square root, so we want the square root at the bottom. But on this one, what would the derivative be? Whoops, sorry. What are we going to have? 30 times this to what power? Times 6x. Okay, and they do want you, they do expect you to go ahead and multiply these two. So 180x times 3x squared plus 5 to the negative 7. Is that good? Okay. When you see something with the radical, first thing usually if you're talking about derivatives, you want to rewrite it so that you have fractional exponents. Did that work? Yes. Oh, good. No, I'm sorry. But that's good. Save money. Okay. Now that's all on video, so you'll be on video. Okay. So we'll rewrite this as 8 times that to the 1/2, and then we're going to use the chain rule. So f prime of x is equal to, what's 1/2 of 8? 4 times this to the what? Negative 1/2 times, what's the derivative of the inside? 6x. Okay. And then we can go ahead and we'd have 24x times this. And this is one of those times where they started with a radical. We've got our answer with negative exponents. They want it back in a radical. Okay? So if we're doing that, what's that going to look like? Over what? Because the negative said change position, the 1/2 said it was a radical, square root. Okay. Questions on that one? Good. All right. What do you recognize about number 4? It's a product, and within that product, you're going to have some chain rule stuff going on. So I think writing a roadmap might not be a bad idea. So we have 3x plus 4 to the third times the derivative of this guy plus that guy. Is that a positive 3, not a negative, is it? I don't have the problem set. Is that right? Okay. Times the derivative of the other one. Okay. So we are taking the derivative here and here. And we have chain rule on both of those. Okay. So we have 3x plus 4 to the third times, what's the derivative of that guy? Negative 2 times 2x plus 5 to the what? Negative 3 times 2. And so actually, maybe that should be a bracket. All right, everybody see what we did there? The derivative of the inside. If I'm taking the derivative of this thing, it's -2 times that to the -3, and then I always have to multiply by the derivative of what's inside. So that's that other 2. Yes, that's the chain rule. Plus 2x plus 5 to the -2 times, we got chain rule going on again, and that'll be 3 times 3x plus 4 to the what? Second times what? 3. Okay. Okay. All right. Now it's just a matter of cleaning up. So let's clean up within the brackets and see what we get. So we have 3x plus 4 cubed times what? -4 times 2x plus 5 to the -3. I'm still in brackets. Plus 2x plus 5 to the -2 times 9 3x plus 4 squared. I just keep wanting that to be parentheses. All right. We got that. Everybody good there? Okay. Looking at that, if you can look at the whole thing, do you see that we could factor out some stuff? In both pieces, we have some things. What do we have common in both pieces? A 3x plus 4 raised to some power and 2x plus 5 raised to some power. So we're going to be able to factor that out, and we're going to need to do that in order to get the answer the way we need to do that. So we're going to factor out, looking at here, at the 3x plus 4, we can factor out what? 3x plus 4 to the, which one? Second. You want to factor out the smallest. So 3x plus 4 to the second, and 2x plus 5 to the, which is the smaller? The -3, because it's negative exponents. So remember that the -3 would be a smaller number. All right, so that's to the -3. That's what we're factoring out. Make that go up a little bit. Okay, and what's left, let's see. What do we get? When we take this out, that's gone. We still have -4. We take 2 of these out, so what are we left with? 4 times 3x plus 4. Does everybody see that? We took out a 3x plus 4 to the second, and so that left one of those. And we took out 2x plus 5 to the -3, so that's gone. And then we have that's a negative. Is that good? All right, plus, all right, if we take out 3x plus 4 squared, that's gone. So we're left with a 9. Now, this is where you kind of have to remember your algebra. We're actually dividing this into this, right? And so I'm going to write this down here, but then I'm going to erase it. But if you have 2x plus 5 to the -2 divided by 2x plus 5 to the -3, what do you do with the exponents? If you're dividing, you subtract them, right? So this is -2 minus a -3. -2 plus 3. So this just becomes 2x plus 5 to the 1, or 2x plus 5. Does that make sense? Kind of review that algebra a little bit. That's a really common thing that you see in calculus where you have to be able to factor out and stuff like that. And it's not calculus, it's algebra. You remember that because I made y'all do that all the time. Okay, so inside now, we can combine those terms and get some stuff there. Negative 4 times that, negative 12x minus 16 plus 18x plus 45. And we can go even further. What do we end up with? 6x plus 29. And then we had these guys out here. See if I can put in some space. Okay. All right. The only thing that's left that they're going to want you to do is get rid of the negative exponent. So what would happen to that 2x plus 5 to the negative 3? Where does he go? Bottom. So your final would look like this. 3x plus 4 squared times 6x plus 29 over 2x plus 5 cubed. If you don't do the factoring like that, you won't arrive at that answer. Okay? Very well. I mean, you might arrive at it. I'm not going to say you wouldn't. Okay. What is number 5? I don't have it written. I don't think I think I wrote one that isn't that. Do you have 6x minus 7? Let's change that. 6x minus 7. Okay, so whatever it is, if it's on the bottom, you want to rewrite it so that it's 6x minus 7 to the negative 8. And then you're just using the chain rule. Okay, so the derivative of that would be what? I think this is y prime equals negative 8 times 6x minus 7 to the negative 9 times what? 6. And then negative 48 times 6x minus 7 to the negative 9. And I didn't write down the answer to that. I don't know. I'll write or. It'd be negative 48 over 6x minus 7 to the 9th. I'm not sure which one MathLab takes. Double check that. Okay. All right. Now, 6. Is 6 a equation of the tangent line? That's just a theme that will occur a bunch. So you'll learn a new tactic, and then they'll throw a tangent line problem at you, or I will, because that'll be good for you to get. Okay. Now, it says find the equation line to the graph at the given value of x. So they have this business. This is a good time to introduce finding the tangent on your calculator. If you don't have a calculator, you'll be sad. Okay, so you want to have your graphing calculator out. I have 2 others if you don't have one. If you are given a specific x value, you can find the derivative at that value with your calculator. Now, if I'm on a test and I'm asking you to show work, yes, you got to show some work. If you're on Math Lab and you're trying to find the slope at a particular x point, on the calculator. Okay, that's fine with me. You need to know how to do the work, but you also, it's worthwhile to know how to do the calculator. You want to go to Math 8. So push the Math button and go to 8. And do you see that it says in deriv? Okay, that means you're going to find a numerical derivative. And this only works for you if you're finding the derivative at a particular x value. So it says in deriv, and I think it probably has a parentheses, right? Okay, so the first thing you want to put is the function. And we need to put this thing just as it is. So 5x parentheses x squared, I guess that, yeah, that'll be that, minus 4x plus 5 caret 7 and a comma. That should be the way that you would be able to put it in, I'm going to hope. 5x and then x squared minus 4x plus 5, close that, do a caret, which means we're raising it to 7. Okay? So every time you do this, it's function, comma, then you put the variable, which will always be x for us. So put another x, comma, and the x value that you're given, 2. And then you can close that parentheses and hit enter. Hopefully you get 10. 5. You got 5? Oh, it's not 10. That's the y point. Sorry, 2. Okay. F prime. Okay. F prime at x equals 2 is 5. Okay, so what's that? In our equation that we're trying to write, what's 5 going to be? That's your m. That's your slope. How did I get this 10? Plug 2 into the original. You can do that on your calculator. 5 times 2 is 10 times, and plug in 2 here, raise to the 7th, whatever you get, you should get 10. Double check that so that you know how to put things in, you know how to do that. That's just... Do y'all have a question? If you take 2 and plug it in for x here in the original, because we're trying to get, this is your point and this is your slope. So to get the slope, you can do math 8 and then plug in, and so then you're just writing the equation, okay? So here's your x1, here's your y1, and here's your m. And we're going to plug those in to get the equation. So y minus 10 equals 5 times x minus 2. Y minus 10 equals 5x minus 10. What do we get? Y equals 5x? Maybe? Yep. Questions? Was that number 6? Okay. All right. Do we have one more? Oh, hooray. Be out of here a little bit early. Yay. Okay, number 7. I don't think I have it written down. You have your papers. It's a word problem. Says, and you know, if you're like most math students, you look for the equation and you sometimes don't read the problem. I mean, I know I've been guilty of that. But sometimes it's important to read the problem. Most times. Suppose the amount of the mineral remaining in the bloodstream in milligrams T days after the initial injection. T days after the initial injection is approximated by. So then they give you this thing. So T is the days after the injection. Find the rate of change. You might highlight or underline rate of change because that's telling you to do the derivative. It's the instantaneous rate of change with respect to time for 0 days. So haven't they actually given you a challenge to find a numerical derivative? Find the derivative of that thing when t is 0. So can you do it on Math 8? You should be able to say, Math 8, there's your function. It's a little bit of a challenge to put it in. And then comma x, even though it's t, just use x. And then comma 0. And see what you get. I'm just doing it by hand, so what y'all get? Do what? Oh, you're talking. Somebody do that on the calculator, just that. 3 to the negative 3/2. Make sure that 3/2 is in parentheses. Somebody that's good with that? Let's see what we get. Is that after you multiply it by the negative 1? Okay, so say it again. Like that? Well, was it when you raised it to the negative? It was positive. Okay, and so then it's negative. Okay. All right. Because it's decreasing. And it says round to 2 decimal places. So negative 0.19 should be it. Does that make sense? When you see those and it's a numerical derivative, feel free to use the calculator. You should be able to do it by hand if you had to, but we're on a time crunch. We got to use the tools, okay? Any questions? No questions? Okay, let me pause this recording.